Yes, can you hear me? Start करना है क्या?
Yes, sir.
Okay. Only one student is joining. So, okay, we will start. Yes, good morning to all. Myself, Shoaib Pirzadeh, Assistant Professor, Department of Chemistry, Milia Arts, Science and Management Science College, Bid. We are studying thermodynamics second. In the last period, we have proved Carnot's first and second theorem. We have also seen that is efficiency of that is the Carnot theorem. Now today we solve some numerical problems on this topic. So first see that is what are the formulas which are used to solve the problems. So first formula is that is the efficiency. First formula efficiency, it is denoted by that is eta. Remember that it is denoted by eta. It is like small n and it is equal to T2 minus T1 upon T2. So the first formula is that is the efficiency, and that is it is denoted by that is efficiency eta is equal to T2 minus T1 upon T2, where T2 is the final temperature, T1 is the initial temperature. Now the second formula, W, that efficiency is equal, it is the ratio of that is W upon Q2, or W upon Q2 is equal to T2 minus T1 divided by T2. So the second formula is that is W upon Q2 is equal to T2 minus T1 upon T2. This is the second formula. And first formula, that is we have to calculate, this formula is used for calculating the efficiency. Final temperature is given, initial temperature is given, and we have to calculate the efficiency. So we can very simple, that is T2 minus T1 upon T2. And the second formula, W upon Q2 is equal to that is T2 minus T1 upon T2. Rearranging this formula, W is equal to Q2. You have taken in cross multiplication, that is at Q2 here, and T2 minus that is T2 minus T1 upon T2. This is the second formula. By this formula, we can calculate the work done. When heat absorb is given, Q2 is given, T2 is given, and that is the T1 is given. So W is equal to Q2 into T2 minus T1 divided by T2. Or again this rearranging this formula, Q2 is equal to, we have taken Q2 here and remaining term here. So what remains, that is Q2 is equal to W into T2, this cross multiplication W, and I have taken this T2 here multiply by W, that is the Q2 is equal to W into T2, and this in the cross multiplication numerator T2 minus T1. This formula is used to calculate the heat absorb. This formula is used to for calculate the work done. So these are the formulas. Now in these formulas, W is the work done, Q2 is heat absorbed, T1 is initial temperature in Kelvin. Remember that temperature should be in degree Kelvin. If it is in degree centigrade, we have to convert in that is the degree Kelvin. अगर टेम्परेचर डिग्री सेंटीग्रेड में दिया गया है तो आपको क्या है डिग्री केल्विन में कन्वर्ट करना है. T2 final temperature in degree Kelvin. That is how to convert. We have seen in the thermodynamic first, that is while converting degree centigrade to degree Kelvin, we have to add 273. So these are the formulas. Simple formulas are there. Efficiency, and that is W upon Q2 is equal to T2 minus T1 upon T2. And rearranging this, we can W is equal to Q2 into T2 minus T1 upon T2, or Q2 is equal to W into T2 divided by T2 minus T1. So remember these formulas. So by using these formulas, we solve some, that is the problems. Now the first problem, calculate the efficiency and work done of an engine operating between 325 degree Kelvin and 425 degree Kelvin, which absorb 700 joule of heat. So this is the problem. That is, I will repeat again the problem. That is, calculate the efficiency and work done. यानी इसमें क्या है, आपको efficiency मालूम करना है, efficiency ईटा मालूम करना है, और दूसरा क्या मालूम करना है, work done, that is W मालूम करना है. We have to calculate here, that is efficiency, that is eta, and W. Now work done of an engine operating between 325 degree Kelvin and 425 degree Kelvin. That is, two temperatures are given here. Initial temperature T1 is given 325 and T2 is given 425. T1 दिया हुआ है, T2 दिया हुआ है, which absorb 700 joule of heat. यानी heat, the value of heat is also given. Heat की value भी दी हुई है, Q2, the value of Q2 is given and it is 700 joule. Q2 is equal to 700 joule. So this is the problem. Now solution, when we are writing the solution of this problem, first we have to write the given things. So what is given in the problem? T1 is given, that is the 325. T2 is given this 425. Q2 is given 700 joule, and we have to calculate W, that is work done, and that is the efficiency. So which formula we have to use? That is W upon Q2. W upon Q2 is equal to T2 minus T1 upon T2. Or rearranging this formula, W is equal to Q2 into T2 minus T1 upon T2. So this is the formula. We have to calculate the W. Now remaining value, put the value of Q2, put the value of T2, put the value of T1 and T2. So that is equal to, what is the value of Q2? That is 700 joule. So we put the value of Q2 as 700 joule. Now in bracket, T2 minus T1. What is the value of T2? 425. This is 425 minus 325. So 425 minus 325 divided by T2. So that is the 425. Now Q2, that is the 700 into, now 425 minus 345. 425 में से आपको क्या करना है, माइनस करना है 325. तो कितना रहेगा 100, यहाँ पे 100 divided by as it is, that is 425 as it is. Now the 700 as it is, 700 as it is. Now 100 को 425 से divide कीजिए, 100 divided by 425. तो कितना आएगा आंसर? That is the 0.2352. You can use a log table, or that is the calculator also. Calculator is allowed in the examination. So 700 into this 100 divided by 425. This division becomes, that is the 0.2352. 0.235. So this is the W. Now multiply 700 into 0.2352. Now it becomes, that is the 164.64 joule. That is the 700 into 0.2352. It becomes, that is the 164.4 joule. So this is the work done. That is, the answer is 164.64 joule. Now second, we have to calculate the efficiency. Second, we have to calculate efficiency, that is eta. Eta is equal to T2 minus T1 upon T2. Now put the values as already we have solved here. So that is 425 minus 325 divided by 425. Now this 420 I have written directly because we have solved here. So that is 425 minus 325, that is 100. 100 divided by 425. So that means that is 0.2352. This is the value of efficiency. And we have seen that is efficiency is always less than 1. तो यहाँ पर कितनी आई है आपकी efficiency? एक से कम है. देखिए efficiency की value 0.2352, that is it is less than 1. एक से कम है. Efficiency is less than 1, 0.2352. Now sometime percentage efficiency is asked in the examination. Here it is not asked, but we have to, I am showing that is how to calculate the percentage efficiency. Percentage means we have to multiply by 100. So percentage efficiency is equal to 100 into this efficiency 0.23 into 52. And if we multiply this 0.2352 by 100, it becomes 23.52%. So this is the percentage efficiency. Sometime it is asked in the examination, calculate the percentage efficiency. And sometime it is asked that is only efficiency. Only efficiency up to this, okay, that is efficiency is equal to 0.2352. And always it is less than 1. एक से कम है. 0.2352 आंसर है, तो it is less than 1. और percentage efficiency मालूम करना है तो आपको 100 से multiply करना है. 100 into that efficiency, and it becomes efficiency. Percentage, that is called as the percentage efficiency. Understand? Okay, next problem. Second problem. An engine operating between the temperature 25 degrees centigrade and 115 degrees centigrade absorb 650 joule from the source. Calculate efficiency and work done by the engine. Now again the same formula, that is the same problem is there. So I'll repeat again, that is a engine operating between the temperature 25 degrees centigrade and 115 degrees centigrade. That is, two temperatures are given. T1 is given and T2 is given, but it is in degree centigrade. T1 और T2 डिग्री सेंटीग्रेड में दिया गया है, तो आपको कन्वर्ट करना होगा इसे डिग्री केल्विन में. सो यू नो दैट इज हाउ इट इज कन्वर्टेड. दैट इज T1 इज इक्वल टू 25 है, आपको डिग्री केल्विन में कन्वर्ट करने के लिए इसमें 273 ऐड करना है. सो T1 इज इक्वल टू 25 प्लस 273, सो इट बिकम्स 298. तो T1 लेंगे आप 298 डिग्री केल्विन. ओके, नाउ सिमिलरली T2 कितना दिया हुआ है? 115, बट इट इज इन डिग्री सेंटीग्रेड. डिग्री सेंटीग्रेड में दिया हुआ है, लेकिन आपको कन्वर्ट करना होगा इसे डिग्री केल्विन में. सो 115 प्लस 273, हाउ मेनी? 388 s. So that is the T2 is equal to 388. So this is the value of T1. This is the value of T2. We have converted in degree Kelvin. Now again Q2 is given, that is heat absorbed. Q2 is equal to 650 joule. 650 joule दी हुई है Q2 की value. Again we have to calculate W is equal to what, and efficiency, that is eta is equal to what. Now the same formula, that is W upon Q2 is equal to T2 minus T1 upon T2. Same formula is used. Or rearranging this equation or formula, W is equal to Q2 into T2 minus T1 upon T2. Now put the values of T2. What is the value of T2? 650. 650 रखिए in bracket, that is 388 minus 298 divided by 388. 388 में से आपको क्या करना है? 298 माइनस करना है. So 388 minus 298, it becomes 90. That is 650 into this, that is subtraction. 388 minus 298, it is 90, and this divided by 388. So W is, therefore W is equal to 650 into this dividation, 90 divided by 388. It is 0.2319. Use the calculator. So 90 divided by 388, it is, that is the 0.2319. Now multiply this 650 into 0.2319. 650 into 0.2319, it becomes, that is the 150.73 joule. 150.73 joule. So this is the value of W. The unit of work is, here it is MKS, in MKS system, SI system, that is, it is joule. So W is equal to 150.73 joule. Now again we have to calculate the efficiency. Efficiency is equal to T2 minus T1 upon T2. So put the values of T2 and T1 in this equation. Efficiency is equal to 388 minus 298 divided by 388. Now in above we have solved. So again we have to put only values. Again not necessary to again calculate. So only see this calculation. This is again repeated here. You write only that value here. Don't do again calculation, because already we have do the calculation in for above step for calculating the work done. So efficiency is equal to 388 minus 298 divided by 388. I have written directly, that is 388 minus 298. How much? Yes, 388 minus 298 कितना आएगा? 388 में से 298 जाएगा तो
90.
Yes, correct. So here also in the above, that is, it is already we have done the calculation. I am only checking that my sound is मेरा साउंड आप तक पहुंच रहा है या, इसलिए मैं चेक करने के लिए क्वेश्चन कर रहा हूं. ओके, सो दैट इज 90 डिवाइडेड बाय 388. 90 divided by 388. So it is already we have do the calculation, not necessary to again repeat it. That is same. यहाँ पे देखिए आप एग्जामिनेशन में आपको नहीं तो आप क्या करेंगे, आप ये अलग कैलकुलेशन करते बैठेंगे, ये अलग कैलकुलेशन करेंगे, ऐसा नहीं करना है. थोड़ा सा देखना है कि ऊपर हमने ये कैलकुलेशन किया है, यहाँ पर वही है तो वही यहाँ पे लिख देंगे, या फिर से कैलकुलेशन करेंगे तो वही आएगा. Understand? So efficiency is equal to, sorry, that is 0.2319. So this is the efficiency. Now again it is less than 1. एक से कम है. देखिए efficiency का जो आंसर आएगा हमेशा आपको एक से कम रहेगा. परसेंटेज efficiency नहीं बोल रहा हूं मैं, only efficiency. So it is 0.23, that is एक से कम है. It is less than 1. So percentage efficiency is equal to, now again percentage efficiency. Percentage efficiency अगर आपको प्रॉब्लम में कहा है तो मालूम कीजिए, नहीं तो जरूरत नहीं है. Sometime it is asked in the problem, that is calculate the percentage efficiency. तो बच्चे कंफ्यूज हो जाते हैं कि percentage efficiency कैसे कैलकुलेट करेंगे. वेरी सिंपल, efficiency मालूम करना है आपको पहले और उसको मल्टीप्लाई करेंगे 100 से बस. So this is the efficiency. Now percentage efficiency 100 से मल्टीप्लाई कीजिए इसको, that is 100 into 0.2319, that is 23.19. This is the percentage efficiency. So this is the second problem. Next, third problem, again that is the same type is there. An engine operating between the temperature, that is 27 degrees centigrade and 125 degrees centigrade, absorb 750 joule from the source. Calculate efficiency and work done by the engine. Again same problem is there. So I will take directly, that is solution. What is given? T1 and T2s are given. T1 27 there. See here, that is engine operating between the temperature 27 and 125. That is the T1 and this is T2. T1 दिया हुआ है 27, but it is in degree centigrade. Degree centigrade में दिया गया है, आपको कन्वर्ट करना होगा इसको डिग्री केल्विन में. So 27 plus 273, that is the 300 degree Kelvin. So T1 is 300 degree Kelvin. T2 125 degree centigrade है, but we have to convert in degree Kelvin. 125 plus 273, that is the 398 degree Kelvin. Now Q2 is given. Q2 is given, that is the 750. Q2 is given, that is the 750. 750 joule. Now we have to calculate the W and efficiency. Now again the same formula is used here, that is W upon Q2 is equal to T2 minus T1 upon T2. Rearranging this formula, or W is equal to Q2 into T2 minus T1 upon Now put the value 750 into, now what is the value of T2? 390, 98 minus what is the value of T1? T1 300 divided by T2, that is the 398. Now this 750 into, now 398 minus 300, 398 में से आपको 300 माइनस करना है. We can do oral calculation. 398 में से 300 चले गए तो कितने रहेंगे? 98 रहेंगे. That is the 98 divided by this T2, that is 398. Now this 750 into, now you do the calculation of this 98 divided by 398. 98 divided by 398, it becomes, that is the 0.2423. 750 into 0.42423. And if we multiply this 750 by 0.2423, it becomes, that is W is equal to 181.72 joule. So this is the work done. Now efficiency is equal to the formula T2 minus T1 upon T2. Put the values. Efficiency is equal to 398 minus 300 divided by 398. As already we have do the calculation here, that is 398 minus 300, that is 98 divided by 398. I have written directly answer, that is the efficiency 0.2423. As already we have do the calculation here, so I have written the directly. ऊपर हमने calculation किया है यहाँ पर, इसलिए मैंने यहाँ पे directly answer लिखा है. That is efficiency 0.2423. Now see here, it is again that is less than 1, एक से कम है. Now percentage efficiency is equal to 100 into 0.2423. So it is 24.23. So percentage efficiency is 24.23. Next, an engine operating between 373 degree Kelvin and 273 degree Kelvin takes 1897.9 kilojoule of heat. How useful work can be used by it? थोड़ा सा अलग वेट प्रॉब्लम है, थोड़ा मेथड उसने पैटर्न जो है क्वेश्चन करने का चेंज किया है. देखिए, एन इंजन ऑपरेटिंग बिटवीन 373 एंड 273, यहाँ पे टू टेम्परेचर दिए हुए हैं. सो रिमेंबर दैट जो हायर टेम्परेचर है उसे हम क्या करेंगे, ऑलवेज T2 लेंगे. यहाँ पे सर T1 नहीं लेंगे. रिमेंबर दैट हायर टेम्परेचर जो है ऑलवेज टेकन एज T2 and lower temperature always taken as that is the T1. So 373 is the higher temperature, so we can take that T2 लेंगे. Now 273 is the T1 और Q2 दिया हुआ है, देखिए that is Q2, that is 1897.9 kilojoule. So that is the kilojoule. It is here I have written only joule, but it is kilojoule. Okay. Now, which formula we have to use? Again, the same formula, that is W upon Q2 is equal to T2 minus T1 into, that is the T2. So therefore, W is equal to Q2 into T2 minus T1 upon T2. Now put the values. The value of Q2, that is 1897.9, that is 897.9 in bracket, that is T2 minus T1. So T2 is 373 minus T1 273 divided by T2 373. Now therefore W is equal to this 1897.9 into, now subtraction of this 373 minus 273. Very simple. आपको कैलकुलेटर या लॉग टेबल इस्तेमाल करने की जरूरत है नहीं है. दैट इज 373 माइनस 270, दैट इज 100 एंड डिवाइडेड बाय 373. सो देयरफॉर W is equal to, that is 1897.9 into this dividation of this 100 divided by 370 divided by 373, and it becomes 0.2680. 100 divided by 373, that is, it is 0.2680. Now multiply this to a 0.2680 by 1897.9. So it becomes, that is the 508.63 kilojoule. So here remember that प्रीवियस में हमने जूल लिखा था क्योंकि हीट जो है जूल में दी हुई थी यहाँ पे, अंडरस्टैंड, बट हियर हीट इज गिवन इन किलो जूल, इसलिए हमने किलो जूल लिखेंगे, रिमेंबर दैट, नॉट ओनली जूल, प्रॉब्लम में किलो जूल में दिया, देखिए यहाँ पे दैट इज 1897.9 किलो जूल दिया हुआ है। Here also I have to write there kilojoule. Remember that only I have written joule, but it is kilojoule. Okay. Now how useful work can be used? So here we have to take here kilojoule. Answer is that is the kilojoule. Therefore W is equal to 508.63 kilojoule. So that is the W. Next. Next problem. Calculate the amount of heat supplied. Now this is another type of problem, that is here calculate the amount of heat supplied to Carnot cycle. यहाँ पे आपको हीट मालूम करना है, that is we have to calculate Q2. अब तक अभी हमने प्रीवियस प्रॉब्लम में W मालूम करने के लिए देखा, that is W मालूम करना, how that is the W is work done is calculated, but in this problem that is Q2, that is heat absorbed, we have to calculate, and W is given. So I will repeat the problem. Calculate the amount of heat supplied to Carnot cycle working between 95 degrees centigrade and 15 degrees centigrade. Two temperatures are given. One is 95 and second is 15. Take that is lower one, T1 15, and T2 as higher one, that is the 95. Maximum work obtained is 895 joule. Work दिया हुआ है 895 joule, that is W. So we see what are the given in the problem. T1 is given, T1 this 15 lower temperature, that is the 15 degree centigrade. It is in degree centigrade, convert in degree Kelvin, that is 15 plus 273, that is 288 degree Kelvin. Now T2 is given 95 degree centigrade plus 273, so it is the 368 degree Kelvin. So this is T1 is 288, T2 368. Now W is given, maximum work obtained is 895 joule. So that is W is equal to 895 joule, and we have to calculate Q2. देखिए प्रीवियस प्रॉब्लम में क्या था, Q2 दिया हुआ था, W मालूम करना था, और यहाँ पर क्या था, यहाँ पर क्या है, W दिया हुआ है, Q2 मालूम करना है. So what is the formula? W is equal to Q2 into T2 minus T1 upon T2. Therefore rearranging this formula, Q2 is equal to this, Q2 is equal to ये W, ये T2 से मल्टीप्लाई कीजिए W को, T2, और ये नीचे जाएगा इधर, T2 minus T1. Therefore formula is Q2 is equal to W into bracket T2 divided by T2 minus T1. This is the formula for calculating the heat absorbed. Therefore Q2 is equal to, what is the value of W? 895 in bracket. This T2, what is the value of T2? 368 divided by, now T2 minus T1, 368 minus 288. So if you solve this, that is Q2 is equal to, that is 895 into 368. Now this 368 minus 288, 368 minus 288, it becomes 80. Remember, do the calculation. 368 minus 288 become 80. Now this 895 into 368 divided by 80, that is, if we do the calculation of this, it becomes, that is 4117 joule. So Q2 is equal to 4117 joule. ये जूल में है, और if we convert this heat, that is into kilojoule, so we have to, that is divide by 1000. अगर जूल को किलोजूल में कन्वर्ट करना है तो 1000 से डिवाइड करना है, और किलोजूल को जूल में कन्वर्ट करना है तो क्या करेंगे, मल्टीप्लाई करेंगे 1000 से. So this is the value of Q2 is equal to 4.117 kilojoule. You write in the answer in either one form, that is जूल में भी लिखे तो चलेगा या किलोजूल में. Okay, next problem. Now calculate efficiency and the amount of heat supplied to Carnot cycle working between 40 degrees centigrade. T1 दिया हुआ है 40. Convert in, that is the degree Kelvin, 300, that is 13 degree Kelvin. And 120 degrees centigrade, T2 120, convert in degree Kelvin, plus 273, 393 degree Kelvin. T1 होगा 313, T2 होगा 393. Now W is given. Maximum work obtained is 475 joule, and we have to calculate Q2, that is heat supplied. उसके साथ आपको efficiency भी मालूम करना है, efficiency. Okay. Again use the formula. W is equal to Q2 into, that is the T2 minus T1 upon T2, or that is the Q2 is equal to W into bracket T2 upon T2 minus T1. Put the values. Therefore Q2 is equal to this 475 into 393 divided by 393 minus 313. 393 में से आपको 313 minus करना है, so it become 80. And if you do the calculation of this, see 475, 393 divided by 80, ये इसका आंसर आएगा 4.9125. And if you multiply these two, that is Q2 is equal to, that is 233.43, that is 2333.43 joule. So this is the heat absorbed. Now efficiency, it is very simple. T2 minus T1 upon T2. T2 की वैल्यू रखिए, T1 की वैल्यू रखिए, डिवाइड कीजिए 393 से. So if you solve this, efficiency is 0. That is the 2035. Again it is less than 1. एक से कम है आंसर. कंफर्म करना है 1 से 1 है क्या आपका. Now percentage efficiency मालूम करना है तो 100 से मल्टीप्लाई करेंगे. Now the next problem. Now the same type, that is the calculate the efficiency and amount of heat supply to Carnot cycle working between 310 degree Kelvin and 400 degree Kelvin. Maximum work obtained is 675 joule. Again same type का problem है. सबसे पहले हम देखेंगे given things. What is given in the problem? T1 दिया हुआ है. T1 कितना है? 310. It is already in Kelvin. तो as it is रखेंगे आप 310. T2 400 और W 675. We have to calculate Q2, that is heat absorbed and efficiency. Now the same formula, W is equal to Q2 into T2 minus T1 upon T2. Therefore, rearranging this formula, Q2 is equal to W into T2 divided by T2 minus T1. Now put the values. W 675, T2 400. Now T2 minus T1, that is 400 minus 310. So 675 into 400, this subtraction 400 minus 310, that is 90. 400 में से 310 रहेगा.
T2 डिवाइड बाय T2 ले सकते क्या हम?
T2 divided
फॉर्मूला तो W is equal to Q2 T2 minus T1 by T2 है.
नहीं यहाँ rearrange किया हमने फॉर्मूले को. ये W इधर,
अच्छा ठीक है,
तो फॉर्मूला है ना, ये Q2 इधर लिए तो ये W किधर लिए ना हमने यहाँ पर. ये Q2 as तो ये क्या होगा, ये ऊपर जाएगा न्यूमरेटर में.
हाँ.
T2 minus T1 नीचे आएगी. क्रॉस मल्टीप्लिकेशन ये यहाँ पे देखिए, ये दो फॉर्मूले. अंडरस्टैंड. Q2 ये Q रखे हमने और W क्या किया है, Q2 is equal to W, देखिए W into T2 minus T1. Q2 is equal to, ये W as it is रहा, ये नीचे ये T2 और W का मल्टीप्लिकेशन किए, W into T2, और ये नीचे जाएगा T2 minus T1. अंडरस्टैंड.
यस सर.
देखिए क्रॉस मल्टीप्लिकेशन है इसमें. ओके, आई विल नेक्स्ट पीरियड में सिंपल तरीके से, और ये जो क्या क्रॉस मल्टीप्लिकेशन किस तरह हुआ है आई विल एक्सप्लेन, बिकॉज ओनली 2 or 3 minutes आर रिमेन्स. ओके, दैट इज 675. जैसा A डिवाइडेड बाय B इज इक्वल टू C डिवाइडेड बाय D है, तो रीअरेंज करेंगे तो क्या होगा, क्रॉस मल्टीप्लिकेशन AD इज इक्वल टू BC. तो वैसे यहाँ पर भी देखिए ये. अंडरस्टैंड. So Q2 is equal to 2929.97 joule, and efficiency is equal to, that is the same simple formula 0.225. So I दिस इज द इफिशियंसी। स्टार्टिंग में मैंने फॉर्मूले में दिया है, 1 मिनट देखिए इसमें, देखिए यहाँ पर W, ये W एज इट इज रहा है, W डिवाइडेड बाय Q2 है, T2 माइनस T1 अपॉन T2 है, देयरफॉर W यानी ये Q2 को खाली इसको मल्टीप्लाई करना है, Q2 को क्रॉस मल्टीप्लिकेशन किया हमने इधर जाके, ये एज इट इज रहेगा एंड नॉट इन द ब्रैकेट, सो दिस यहाँ पे ब्रैकेट में लिखा हूं मैंने, अंडरस्टैंड। तो Q2 और देयरफॉर Q2 मालूम करना है तो क्या ये Q2 एज इट इज रखेंगे, देखिए यहाँ पे Q2, ये Q2 एज इट इज, Q2 एज इट इज, और फिर क्या होगा ये W, ये T2 फिर इसके पास जाएगा W के साथ, T2 माइनस T1, और ये नीचे आएगा, दैट इज द T2 माइनस T1। सो ओके, सो यू सॉल्व मोर
Yes, sir.
फ्रॉम द बुक। If you have any difficulty, write in the chat box. Okay, we will stop here.